Hi everyone, welcome back to another episode of my IG-11 build. In this episode, we're going to take the files that I started and convert them into a belt drive stepper motor system. That seems to be working a little bit better for me, and I will show you all my fusion files. We'll strip this guy down to just the bare tube and then work our way up from the bottom up, and I'll show you how he works with the code. So stick around, let's get started. So here is an IG-11 stepper motor, and I use these in my C3PO head, and I like them because they have considerable torque. They're 12 volt, they're relatively small, but they're very inexpensive compared to servos that would drive this whole system, and they're quiet as well. So I thought I'd give it a try and see how it goes. So I've got 3 of these in my IG-11 head. So I'm just going to go through from the ground up kind of what I've done to the animatronic files that were put together through Droid Division and Andrew's wonderful models, and let's take a look and see how I've changed them. So first of all, let's take a look at, let me get rid of the NEMAs and look at the tube that drives this whole thing or connects everything together. So there's a head tube and a body tube, and I've got them different colors right now, but they're actually the same tube. So according to the specifications and the instructions, just cut that tube to length, and I'll explain what these holes are for in just a minute. The holes are primarily on this side here, which I call the left side, because this side here, this one here, that's front facing. So I'm going to say that's the front, this is the left, and this is the back, and the back has one hole at the very top. So just bear in mind that this is all one tube. Now what I've done is I created this little model right here and put a hole through it, because what that does is it keeps the head tube separate from the body tube, and I can put this in my vise and cinch this down, and I know that this isn't going to move, so everything's based off that. And then eventually I'll take this sleeve off, and this will actually get pushed right into the body section of IG-11. So let's start at the bottom here, and as you can see, the neck bottom, what I did is I sliced it and I put some holes around it, alignment holes, because I printed this in 2 parts. And since I've printed this, I've got a new printer which would probably do a pretty good job of printing the whole thing all at once, but this is my original model. So that's what the bottom looks like, and then the top section of that would fit on top like that and then get glued in. So I'm not going to show you all of the bearings that go in here, but just assume that there's bearings that all right in here. Now, as you can see over on this side here, I've modeled in some cutouts, and they don't have to be this specific. Basically, you really only need these bottom ones here, and I actually ground them away with my Dremel. I didn't reprint this thing, but the NEMA is tightest on the bottom section, so I cut those in without cutting them through on this side, just being very careful. And that's the only tight section on here. Now I found the NEMA 17s to be adequate torque, but because everything rests on this section, there's more torque required to turn the whole bottom section, and they ended up skipping steps. So I didn't like that, so I tried to combat that problem a couple ways. So I'll just show you what I did here. Now let me get rid of this section here and maybe this section here and show you the mount that I made. So I made this mount here, And there's a hole here, and you just put an M4 bolt through just far enough so that it can actually get screwed into this plastic part here and just stick slightly into the aluminum tube. It's not really holding the whole unit on. What's holding it on is an M3 bolt here with integrated holder for the nut on the other side, and this M4 just stops the stepper mount from moving up and down if that ever happens. So it's just a safety precaution there. So let's go down and take a look at the bottom NEMA. So the NEMA sits inside of here. It's got 4 holes to screw in some bolts to mount that in, and you can see on this side it's quite flush with this, so it just barely fits into that bottom section. And let's go back up to top here. Now the lower face inner looks like that, and you can see that this is the original gear that the servo gear was supposed to be attached to. So I'm going to keep that there, and what I did is I modeled in a pulley that looks like that. This is a GT pulley. It's modeled for a specific belt. So the belts that I bought look like this. They're just regular 3D printing closed loop belts. All of them are the same. They're 160, which means that they're 160 millimeters, and they're all 2 GT pulleys, so they all have the teeth oriented correctly for my application. So they fit around this, and this model I printed on an FDM printer at 0.1 resolution in it, and I just popped it on and it worked fine. But because I have a resin printer, I resin printed this just to get a little bit more detail out of it, and hopefully it'll last a little longer. So the pulley that it goes to, or the other pulley that it goes to, so the belt goes from here to here, looks like this. It's just basically, let me just take off this part here. It's basically a 3D printer application for these belts. Now this one here isn't exactly the one that I used. I started off with this one. It's a 20 tooth, and I found that my stepper was skipping steps, as I said. So what I did is I found one that's got 16 teeth, so it's slightly smaller. So it's a smaller pulley here plus this pulley here and the belt on there, and it gave it a little bit more torque. So I've got all of these in a link in the description eventually on a video where I'm going to post all of my parts in the near future. So that's what it looks like. And then what I did is, to combat the torque as well, is I made this red piece here. So let me just get rid of the tube so you can see what this looks like. Now this was just kind of rubbing on the tube as the pulley pulled on everything, and it was causing too much tension. So I modeled this, and it goes directly in the center of this inner face, the lower inner face, and it holds a bearing. So the bearing looks like that, and this is the bearing that I used. It's 42 millimeters across, 30 inside. And in order to get this red piece here, this bearing sleeve, mounted directly in the center, I printed this spacer. So you basically glue the red part in, pop the spacer in temporarily as it all dries, and then you know it's dead center, and then you can take the spacer out. And then the bearing goes in, and then what snaps on top of the bearing is this that holds around the tube. So it looks like, let's go to the tube here. So it looks like that. So this whole thing spins a lot better now, and less tension on the belt and the stepper motor. So that's the bottom section. Let's move on up to Oh, that's the top section that goes in. So it gets glued in, so that's what it would look like eventually. So let's just leave that off and take that off, and let's move on. So the drive plate. So this is the original drive plate, and it fits right inside of there with the bearings. But I cut this and modeled in a section where the middle stepper can go. And by the way, there's holes here for all the wires to go through. This is a 10 mil hole, so I can get the wire connector right through here. And I did that right up here as well. So let's take a look at the middle NEMA. It goes right into there and gets bolted in. And then on top of that, let's move this all the way up here. We have our pulley that goes onto the NEMA, and then the eye segment lower part. So as you can see underneath here, there's the original gear again, and then the same model just snaps right onto there. I just put a little bit of E6000 glue on there to hold it on, but it's been holding really well. And then on top of that is the top part of the eye section, the upper. This is where the servo goes to hold the mechanism to make the eye tilt up and down. Now, in the original plans, this whole thing would rotate freely past 360, and there was a slip ring on here to prevent it from the wires from getting tangled up. But I wanted to avoid all that. I'm not making mine totally screen accurate. It's going to move about 300 degrees left and right. So the way that I did that is I modeled in a limit switch stop. And the limit switch looks like this. So this is the middle part, the middle limit switch holder, and it gets screwed on here to hold that tight. And then I have just a regular limit switch that are common in a lot of 3D printers. And what happens here is when this whole thing rotates, that green stop will click this. So in the original sketch, what happens is when it starts, this middle section here rotates slowly until it finds the switch, contacts, tells the stepper motor this is now going to be 0 position. Don't go past 0 and 1500 steps or whatever. So it'll all go within these parameters and never pass that. So that's how I stopped or got away from using a slip ring. So that's the limit switch, and then moving on up, we have our top stepper mount. So let's take a look at the NEMA that connects that. So it looks like that. And pulley goes on top of there. And then the upper pulley gets mounted into the dome. So you can see right up in there, it's glued in. And there's an access hole for a couple things. Now, this one here, what I'm going to do is I'm going to put in a rubber grommet so that the wires can go through there. And then the servo wires from the eye tilt are going to go through here, as well as the lights, the wires for all the LEDs are going to go through here as well. And because this thing's turning all the time, I don't want the wires to get ground out by the or worn away from the sharp edge of the aluminum. So there's going to be a rubber grommet that goes in there to stop that from happening. Now this gets pushed in with or attached with an M4 again, and then an M3 bolt to hold everything on. And then the dome gets on there. So let's leave the dome on because I'll show you this top section here can also not rotate past 300 or so degrees because the wires will get all tangled for the eye segment. So I made another limit switch holder. This one's a little bit shorter, and the limit switch goes in this orientation, and it gets activated by this little printed stop that gets glued onto the top of the dome. Now, as you can see here, I've been cutting these little circular access holes in. The reason for that is that, and you can see the one down here, so that when I put this on to get the belt around here, I just use a little screwdriver and I can slide it around over top of there. And by the way, all of these gears, I've removed the very top flat shroud that goes on there. You can pry that off with a pair of pliers because we don't need that, and you wouldn't be able to get the belt on in such short confined space with that on top of it. So anyways, so that hits that, and same thing on the beginning part of the sketch. The whole thing will turn in this direction until it sees a stop. It'll say that's 0, and then it won't go past the other side at all, or shouldn't anyways. And then to hold everything on top of that is the plug. There's a plug here that goes into the tube, and it gets screwed in to hold this all in. And if I could, maybe what I'll do is I'll take away the tube and this and just show you what that looks like. Get rid of that and the forehead dome and maybe that guy there. So you can see that the plug looks like this. It's got a area where wires can go through on this side. In here it's got a captive stud or a captive bolt for the screw that goes in here, and way underneath, you can't see it through this, but there is another captive nut for the very top. Okay, so let's put that back together and let's get down to here. There we go. And then at the very end, the top cap gets put on and a screw goes in from the top into that plug. So that's my setup so far. It seems to be working, and let's get all these guys on there. Yeah, so it seems to be working. I will show you now live what that looks like on my animatronic IG-11 head, and then in our next episode I'll be showing you how I hook up the eye tilt and all of the LEDs. They're going to be probably neopixels in here so that I can activate bright colors, maybe change the colors if I want to in the sketch. So really what happens is you turn on, activate the IG-11, the middle section rotates, set 0, and then the top rotates, set 0, and then it goes into random positions. So all of these sections, the bottom one spins in random positions at random speeds, same with the middle one, same with the top one, and that'll happen until you shut it down or activate self-destruct, and we'll talk more about that in the future. Thanks everyone. All right, let's build this thing from the ground up. I've got my square tube here fastened into this vise just to hold it. And here's that spacer that I made. Just goes down to there. So this is actually where the head starts, and then this lower part here will be where it goes into the body. All the wires come through here. There's like 7 sets of wires. I've got 3 sets for stepper motors, 2 for limit switches, 1 for the servo, and 1 for the LEDs. And I've got a bunch of extra holes in the tube just because I've been experimenting with things, but in my PDF eventually I'll have the exact location for all these holes. So there's a circuit board that's been controlling it. I'll go into more detail about the electronics a little bit later on, probably another episode. But for now, let's take a look at the bottom unit. So here it is here. As you can see, the stepper is really tight in this bottom section. So down here is where I just used my Dremel and I carved away some spots for the bottom of the stepper to fit in so that it's nice and snug. So my holes for all the access points are all on the left side. I call this the left side. This is the front, so there's nothing on the front. and on the back there's one hole here that will be for the top limit switch. So let's put this in, and the way we put it in is slide it down there. So it goes down to the bottom so that those little carved out areas are at the back. All right, so now that's sitting in there properly. We're going to attach the stepper motor, and we'll try out the bottom section. So before we do that, I just want to show you how it'll look with this piece in here. So there's my area right in there for this bearing, and it's got the top part is the section that slides over top of the square tube. So the bearing just goes in here, gets pushed in, so it can turn a little bit easier. And let's look underneath. So there's the section there that I resin printed. This is the pulley for the belt, and it just pops over the existing gear, and I just used some E6000 glue to put that in. And there's an access hole right over here to help me get the belt on. And let's put that aside for now, and we will get our stepper involved here. So let's just take a look at the pulley here. This one is different than most. So like this is what you normally get. This is a 20 tooth, and they always have these top caps on them. So I just use a pair of pliers and I pull that off. And this is a 16 tooth. So you can see there's a bit of a size difference there. Smaller, the number of teeth here will give you a little bit more torque, which is what I need for especially the bottom section, but I just use the same setup on all of them. So over here I've got a M4 bolt, and it's going to go into the tube, but not right through. It's just going to go far enough to prevent this from moving up and down. And then this M3 bolt with the captive nut on the other end is going to hold the whole thing on. You can see that there's a bit of movement areas here, but this actually doesn't move at all. It's super tight in there. And then the stepper gets plugged right in. You can see down there, it's just sticking out there. I'm going to pull it out once I slide this over and pop it in. And this is the hole where the M4 bolt will go in to prevent it from sliding around. So let's put that in and see what it looks like. Now the way I put the, that was a bit of a tight fit there, but the way I put the belt on, and this is the belt here, it's a 160, so that's 160 millimeters, and it's going to go just around here. And then I have my access hole, and what I do is I just take a screwdriver and I pull back on the inside there just to give it some tension. Come on. And then I'm going to slide it over top and down and line it up with the pulley on the stepper motor. And I can see through the access hole that it's engaged. So let's try this out, see what it looks like as it does some random movements. Just bring this down here, turn on some power. It's nice smooth motion. And we're ready to go with our next layer. Okay, here's the drive plate with the stepper installed. As you can see, it comes up right, butts up almost right against the square tube. A little bit of leeway for varying the gap and the belt if you need to. And then I've got my stepper motor connection already coming through there. So this goes like this. So the stepper motor's at the back. It's going to go down and we're going to connect that up. All right, here's the eye segment section. I've just temporarily put the eye on here just so you can see it move. And I'm going to put this pulley or this belt through here. And then using a screwdriver from the other side, what I'm going to do is I'm going to add some tension like that just to get it over top of this pulley here. So let's throw this over. Bring it down, and there we go. Now we're going to need to put in our limit switch. This is what the limit switch looks like. So I've got it mounted underneath on this one. So it's got some M2 bolts that go through that hold that on, and then I just have a servo connector on here. So there's 3 wires, red, black, and a signal, and this is going to go over top of here like that and down. Now the wire for it is tucked away in here. Let's pull that out and then hook this up, white to white, red to red, black to black. And just make sure it's up and out of the way. I might hot glue that in there. And then it has to be the right height as well. So you want this to go around and make contact with that stop. So we will tighten this up here. And at the same time, you want it like high enough to get past the servo horn once that's installed. So it'll go around, and what you'll see in the code when I start this up is that it'll start to move in this direction slowly, and then it'll make contact, it'll stop, it'll move back, and then from there it'll do random movements from here all the way to here and won't go past those limits. So let's check that out. So it turns, finds a limit, and then sets the random positions for the middle and the bottom. All right, from here we're going to move on to the next section, put in the stepper motor and the limit switch for the top. Okay, top section, here's the sensors section. I'm going to probably be swapping these out for individual NeoPixels in the future. So that goes on like that. There's our top dome. And I'll put the belt through, stick it in from the top. There we go. Here's the stop. Now what we do is put in the limit switch bracket and limit switch. That goes right down. Feed the connector through. So we have that. And then turn this so that it's off the ground but hitting the stop. Tighten that on. Plug in our connector. Make sure it's tucked up out of the way. And we'll try that out. Alright, let's activate the sketch, and you can see how it sets up. So that bottom one zeros, and the top one zeros, and then it goes into random. So the randomness is the speed that each section turns is random, the time between the movements is random. Haven't quite set it all up the way I want it exactly yet. And then we've got our limits for the top and the middle. Now the last thing we're going to do is hook up the very top cap. It's going to go on like this. And then it'll be screwed down through, I believe it's an M3 through the top, but it'll actually, before that happens, I'll put the top plug in. So this plug has a integrated nut inside there, and then one on the side. So this will go in into there, get screwed in, and then the top cap will go on with that through that hole there. Hey everyone, thanks for watching this video. Next time we'll look at the iTilt and the NeoPixels in the sensor section here. Add that to the code and make sure that's working properly. God bless you, and we'll see you real soon.